In today's video, we'll be talking about a brand new feature that Ubiquiti have added to their UniFi access points, and it's known as PPSK. If that sounds familiar, you may have seen my previous video where I set up DPSK on my Ruckus access point. It's a very similar technology. Different vendors give it different names. Some call it PPSK, some call it MPSK, Ruckus call it DPSK, various different names. But essentially it all does the same thing, where it allows you to have a single SSID with multiple different keys associated with it, and depending on what key you use will define which VLAN you're associated with. This is something that a lot of other vendors have supported for quite a while. Ruckus sort of seemed to pioneer it initially, various vendors picked it up, but Ubiquiti have always kind of lagged behind and never supported it, but they seem to have finally introduced it. It's interesting seeing lots of vendors jumping on this technology in the last few months. It was relatively obscure for quite a while. Alta Labs brought out their access points that quite heavily promoted it, and since then Ubiquiti are now supporting it. I think Grandstream introduced support as well for it. It's becoming quite a widely used technology. So let's talk about it. So as I mentioned, the way PPSK works is rather than creating a different SSID for every VLAN on your network with its own pre-shared key, you can create a single SSID, associate a bunch of keys with it, and then whichever key your client uses will define which VLAN it's associated with. This is very useful technology. First of all, in the case of UniFi, you're limited to 4 SSIDs per access point. So if you've got more than 4 VLANs, you'd be out of luck with sort of traditional technology of creating separate SSIDs. But with PPSK, you can create a single SSID and associate as many VLANs as you'd want with it. It's also not best practice to just broadcast an absolute ton of SSIDs. For every SSID, every access point has to broadcast beacons, where it has to send out a little bit of data every so often to tell nearby devices that are scanning about each SSID. And these beacons are transmitted at a very low data rate. Typically, they'll be transmitted at the lowest data rate that the access point supports, because legacy clients will need to be able to receive much lower data rate packets to be able to see them. This means that because you're transmitting a lot of beacons from a lot of different access points, all at very slow data rates, it wastes airtime. So you can end up unnecessarily wasting channel utilization and filling it up with beacons for all your different SSIDs rather than actual data that you'd want to transmit. And that can slow the network down quite considerably. And it's quite a big problem in large commercial places where you've, say, got an office building with tons of access points, potentially lots of different companies with different SSIDs broadcasting. You can have absolute nightmares just from the amount of beaconing. So with PPSK, you can cut that down because now each access point can only broadcast a single SSID rather than 4 or even more. For a home environment, this can be pretty useful. If you've got a network like mine where you've got a lot of different VLANs to segregate out devices, you might have a bunch of different VLANs that you'd want to have wireless. For example, on my network here, I have my main LAN network, I have a guest network, and I have 2 separate IoT networks. One for IoT devices that require internet access, and one for IoT devices that don't require internet access. And then they're all managed separately in the firewall, and they all run on separate VLANs. So without PPSK or DPSK functionality, I'd have to have 4 SSIDs. Then say I've got an IP camera that was wireless, and I wanted that to be on its own VLAN, well, I'd need a 5th SSID, and so on. Whereas with PPSK, I can just have 1. Which is really good. Another use case for this type of technology is places like serviced office buildings, where you can rent a single office or a couple of little offices or just individual desks. They're very popular nowadays. Many of these providers will also provide networking to your business. So if you're a small company that just wants to have a little office and you don't care about technology, you've not got an IT department, all your devices are just cloud-based, they'll provide you with some network ports in your office, they'll provide you with wireless, they'll provide you with internet connection. And the way they tend to do it is that each office or each company in their building will get a dedicated VLAN, so all their devices are kept private to them. This is very easy when it comes to network ports because they'll just all go into switches and the switches will assign the VLANs. However, when it comes to wireless technology, it gets a bit trickier. Some of these businesses will just broadcast an SSID for each company, but that means you're broadcasting an absolute ton of SSIDs and you have the issue with beaconing. And you either have to broadcast it across all your access points, broadcasting all these SSIDs to give full coverage over your building, or you end up broadcasting specific SSIDs on certain access points based on where the offices are, and it gets a bit messy. Alternatively, you can use enterprise authentication, we'll talk about that in a minute, or you can do what I've seen in these service office places in practice, where they set up a captive portal, which is just ridiculous, where you connect an unsecured network or a network with a WPA2 pre-shared key, and you get a captive portal, you log in with your company's credentials, and it drops you on your VLAN, which is ridiculous, because that is an absolute nightmare, dealing with captive portals, and yeah, at that point, I would put in my own access points. And this is the kind of environment where PPSK would work brilliantly, because what you'd have is you have access points deployed throughout the environment, single SSID being broadcast, Each company gets their own pre-shared key, they can put it into all their devices, and it'll drop their devices onto their dedicated VLAN, as if it's their own access point. And because all the access points in the building could broadcast that SSID, staff could have full coverage throughout the building, which could be really good because these places quite often have little cafes and meeting rooms and stuff where staff might want to move around outside of their own company's office. So yeah, that's a couple of use cases where this technology would be really useful. Situations where you'd have a lot of different VLANs and you want to ideally have them on as few SSIDs as possible. So what about WPA2 Enterprise, you may be asking? Because that would accomplish a very similar thing. You'd have an SSID broadcasting, you'd have a Radius server as a backend with all your users, and each user would log on with a username and password. And each user can then be assigned to a VLAN. So in a home environment, you could have your different VLANs could have their different users, and depending on what user you'd use would define which VLAN you're dropped onto. In a serviced office building, each company could get their own username, or each person could get their own username, and that would work. However, there's one big downside with that. Not all devices support WPA2 and WPA3 Enterprise. If you're talking phones, laptops, all that sort of stuff, they'll support it. But things like games consoles, TVs, IoT devices, I mean, my washing machine connects to Wi-Fi. Those devices don't support WPA Enterprise. So if you've got a single SSID broadcasting a WPA Enterprise network, those devices won't even connect to it. It's just impossible. Whereas with PPSK, any device that can connect to a WPA2 network with a pre-shared key can connect to it. As far as the device is concerned, it's just connecting to a normal network. It doesn't know about the PPSK background behind it. It'll just work. So it's absolutely great from a device compatibility perspective. So yeah, it's a really cool technology. I've had my Ruckus DPSK set up at home working for a couple of months now, and it's worked absolutely brilliantly. And it's really nice to see that now UniFi have introduced it. So what we'll do in this video is we'll take a look at the setup I have here, just talk about the hardware very quickly. We'll then jump into the UniFi controller, take a look at how you can configure it, take a look at it working, and we'll talk about one big catch that this has that'll be interesting to see how it's handled going forwards, but we'll leave that till the end of the video. So for now, let's take a look at our setup. So what we have here is my UniFi Nano HD access point. This used to be my main access point. I've now replaced it with the Ruckus access point, but I still have it, and I think I'll actually hold on to this just as a test device so I can test UniFi stuff. So it's a nice little UniFi Nano HD access point. Wi-Fi 5 AC4 stream is pretty good. Works really well, so that's my Nano HD there. And then for a controller, we're using a CloudKey Gen 2 Plus. But as far as I'm aware, this will work for any kind of UniFi controller. So if you've got a CloudKey, if you've got a Dream Machine, if you're self-hosting your controller, you should still be able to do this. Just need to update it to the latest version. So that's the test setup we have here. What we'll now do is we'll jump into the UniFi controller, take a look at the setup we've got now, switch it over to using PPSK, and take a look at it working. Okay, so here we are inside the UniFi controller. And as you can see, we have a single access point here, which is my Nano HD. Now, if we go into settings, we can take a look at what networks we have. So with the setup, because it's a CloudKey and I've got my own separate router, this isn't a UniFi network anymore. I've basically got these networks just set up with a third-party gateway router, as they call it. They're essentially just VLAN-only networks. So this is how you set up a UniFi network if you've got an external router and you just want to set up certain VLANs on the access point. If you have a UniFi router, so a Dream Machine or something like that, it would be a very similar setup here. It would just be a case that rather than these networks staying third-party gateway, these networks would be set up on your router and it would show an IP address subnet here and stuff like that. But the process is basically the same. So for the sort of test setup, we have 3 different VLANs, so LAN, IoT, and guest. And then the native network is the management network, native VLAN. UniFi does this thing where the management has to be on the native VLAN on all your switch ports, so that's management there. So we've got management, LAN, IoT, and guest. Then if you look at Wi-Fi, we have the sort of setup you'd have on a typical environment where you have multiple SSIDs with multiple VLANs. We have 3 different networks. We have one for LAN, guest, and IoT. And if we go into each of these, you can see we have that set up with a pre-shared key. And then if you look down here, we can see we have the network is defined as LAN, and that has a VLAN. So this is on VLAN 1000, IoT is VLAN 1002, and so on. UniFi just kind of abstracts the concept of a VLAN by giving it a network name, but by this saying IoT, it just means that this SSID is linked to VLAN 1002. As you can see, each of these has its own password or pre-shared key. So this is where you would instead set up private pre-shared keys, or PPSK. So you can see there's a checkbox down here to enable that for this particular SSID. What I'm going to do here to test, I'm going to create an additional SSID just for PPSK. Once I've done that, I could basically delete each of these separate networks and just go with that new PPSK one. So we can go create new. I'm going to say UniFi _PPSK. Now, we're not going to set a password here. Instead, we're going to pick manual here instead of auto and tick private pre-shared keys. And when you do that, you'll notice the password box up here disappears, and instead it starts asking you to enter some pre-shared keys. So what you would do is you'd pick your network. So we say, right, we want to do LAN. So a pre-shared key for the LAN. So we're going to go LAN pass 123, something like that. Just keep very simple password. That'll do. And hit save. And then hit add. That's now added, and you can save that. So with that save, we're going to add that network now. We're going to have that new network. We can go in here, and currently it's just set up with one private pre-shared key. So you can start with just one key. That's all you need. But we can create more. So now we can go up here and press edit. We can edit more. So we can say, right, I want another one for IoT, which is going to be IoT pass 123 exclamation mark. There we go. And then we're going to go guest. So guest pass 123 exclamation mark. So that's now our 3 private pre-shared keys on that single SSID. So now that's all done. So we can basically just quit out of that. Oh, I forget to save. Oh, saves hidden behind the dock. That's very helpful. Get rid of the dock. There we go. We can now go apply changes, and that's now saved. So now we have our 4 SSIDs. Now we have LAN, guest, and IoT as the traditional separate SSIDs, and a third one, or a fourth one, that's PPSK. And now if we scan for nearby Wi-Fi networks, we can see we have those 4 networks. We have the guest, IoT, and LAN standard networks, and the new PPSK network. At this point, we could very easily go into here and just remove each of these older networks we're not going to use anymore. So I think we press manage. Yep, there we go. Tick each of these ones that we don't want. You can even just pause them and just disable them temporarily. So we'll just do that for now. You could obviously remove them. And there we go. So we're now ready to test out PPSK. So yeah, there we go. We've now disabled our separate SSIDs, and we now have our single new PPSK SSID. So now let's jump back over to the camera and take a look at this working. Okay, so now let's try this out. So this is the exact same test you'll have seen in my DPSK video. So if you've seen this before, it's not really very exciting, but if you've not seen it before, it's quite cool. So here we have the two different phones, and on both of them we're connecting to the UniFi PPSK network. But as you can see, we have 2 different keys. On the left, we have guest pass 123 exclamation mark, and on the right, we have LAN pass 123 exclamation mark. So these keys are separate. So this is for my guest network, this is for my main LAN. So what we'll do is we'll connect using each of these keys. Then we'll go in and see which IP address each phone's been assigned, and we'll see that they're on different subnets, showing that the keys are being used to define which VLAN we're being associated with. So let's connect each phone, and then we'll take a look at what IP addresses we get. Okay, so now both phones are connected with those new keys, so we can see both of them are on the UniFi PPSK network, but we can go to View More here, scroll down to the bottom, and we can see the IP addresses were assigned. And you can probably just about make out on camera, hopefully it's coming across. On the left, we are 10.114.1.14, and on the right, we're 10.114.0.234. So these are on separate subnets. These are both /24s, but we're on 2 different subnets. So that shows that the PPSKs worked. These phones are on different VLANs from each other, despite actually being connected to the same SSID. And that's basically what PPSK does. It's pretty cool. Okay, so we're now back inside the UniFi controller. As we can see, we have 2 devices connected. We can see they've got the different IP addresses on different subnets again. And if we expand this here, you can see we have the virtual network trigger showing as UniFi PPSK. So that's presumably what they're calling this, is like a virtual network trigger. Interesting. And yeah, we can see 2 different IP addresses there as well. So yeah, that's it working in the UniFi controller as well. So there you go. That's it all set up, and it works really well. Now, the UniFi implementation isn't quite as full-featured as Ruckus's DPSK implementation. On Ruckus, you can do a little bit more. You can set it up like this, but you can also set it up with single-use pre-shared keys that can only be used once. You can set up pre-shared keys that expire. You can set up pre-shared keys that are tied to a device's MAC address. So either the key is tied to MAC address at creation, or it'll bind to the first MAC address of a device that connects to it, and then that key will only ever work for that device. You can also batch create them, so you can create 1,000 keys all at once and then export them as a CSV file. So Ruckus's implementation is a bit more flexible. But UniFi's is a lot simpler. So UniFi, you're only really going to be able to use it to put different devices on different VLANs based on the key. But that has the benefit that UniFi's implementation is much simpler to configure. Ruckus's implementation can do basically the same thing, but it requires a lot more configuration and a lot more understanding through pretty rubbish documentation to figure out how to do it. Whereas on UniFi, it's pretty simple. So yeah, there's that trade-off there. If you need all the features that Ruckus has, you might need to go Ruckus. But if all you want to do is to drop different devices onto different VLANs based on pre-shared key, the UniFi implementation works brilliantly and is really easy to configure. However, as I've alluded to throughout this video and in the title, there's a catch. And this catch doesn't just apply to UniFi, it applies to a lot of other implementations of PPSK type technology. This is something that I briefly noticed when I was setting up my Ruckus access point, and I noticed that you had to pick WPA2 encryption. If you picked WPA3, it would grey out the DPSK option. So I thought that was a little bit weird, but whatever, I just continued with WPA2. But one of my viewers commented and made a very good point. They were trying out the UniFi PPSK implementation, and they found that if they have a 6 GHz radio on a Wi-Fi 6E access point, they cannot use PPSK on that. So I was looking at that thinking, well, that's a bit weird. But of course, it actually makes sense. By its sort of very nature, it seems that PPSK type technology only works with WPA2. WPA3 does its encryption very differently, and apparently it's not possible to do PPSK type stuff with it. I'm not an expert with this kind of thing. But apparently with WPA3, the idea of having multiple pre-shared keys doesn't really work. And with 6 GHz networks, if your network operates on the 6 GHz band, it's required to use WPA3 encryption. Now, this isn't something I really noticed on Ruckus because my access point is just a Wi-Fi 6 access point. And if that person hadn't commented saying this, I would never have noticed because this isn't a 6 GHz access point either. So it was a really good comment for them to point that out because I would have never spotted this. If you have a UniFi Wi-Fi 6E access point, you cannot have a 6 GHz network that uses PPSK because they're kind of incompatible. You either need a 2.4 and 5 GHz network using WPA2 if you want to use PPSK, or if you want a network that includes 6 GHz, you need to therefore use WPA3. Therefore, you have to have separate a single pre-shared key. You can't use PPSK. So this is a bit of an issue, and it's kind of leaving me scratching my head to think what's going to happen to this technology going forwards, because it seems like it's been around for a while in terms of Ruckus having it and a few vendors having it. But with it coming to the more consumer and small business space with UniFi, Alta Labs, Grandstream, those providers, they're all starting to implement it a lot more recently. So it's starting to come out be a fairly recent technology, but it seems like its days might be numbered if 6 GHz and WPA3 isn't going to support it. So if people understand this technology in more detail, it'd be really interesting to get comments on this. What do they think? Is there some way to make it work? I don't know. Now, interestingly, I looked at Ruckus because Ruckus is like the pioneer of DPSK, PPSK type technology. And they have some Wi-Fi 6E access points, the R560 and the R760, I think. And those are pretty new access points from them that support Wi-Fi 6E. And on their datasheets for that, they do state that that DPSK does support WPA3. I also saw a sort of brief presentation from them at some sort of conference where they talked about this. And they did it also in that say that they've developed technology where a client can connect to a WPA3 6 GHz Wi-Fi 6E network using DPSK, which is their implementation of private pre-shared keys. I'll put a card to this video now. It was quite interesting, but they were also a bit vague with details. They described it as magic at several points. And what they seem to be kind of doing is where you would connect initially using WPA2 to a 2.4 and 5 GHz network using your pre-shared key. And if your device is compatible with WPA3 and 6 GHz, what they quote as magic will occur, and the magic will make you magically end up using WPA3 on 6 GHz. So I don't know how that works, but apparently the way they're saying it works is you'll connect using WPA2 and it'll kind of magically upgrade you to WPA3. But the other thing they said in that video is they described this magic as patented magic. So I suspect that maybe CommScope hold a patent on that. So whether it's something that we'll ever see on UniFi or other vendors, I don't know. It may be something that you're restricted to only ever getting this on Ruckus access points for a good long time. It's also not something I can really test because I use Ruckus Unleashed. Unleashed doesn't currently support the 6E access points. I imagine it will in the future, hopefully. They tend to just lag a little bit behind with access point support on Unleashed. So I could, even if I went out and bought an R560 at great expense, I wouldn't be able to test it because I would need a smart zone controller and stuff like that. But yeah, it's an interesting limitation / catch with this kind of thing. UniFi now does support PPSK, but it'll only work on 5 and 2.4 GHz networks, not 6 GHz networks, and only if you're using WPA2, not WPA3. So yeah, we'll need to see what happens long term. Hopefully something happens. Maybe Ruckus kind of release a more consumer-friendly unleashed implementation of it that could be usable, or maybe, I don't know, Unify will pay rights to Ruckus to use that technology and implement that here. We don't know, but currently that's a bit of a limitation. Now, you could definitely work around this. There's nothing saying that even though, yes, PPSK is ideal for having a single SSID with all your VLANs on it, there's no hard and fast rule that you have to have a single SSID. So if I was setting up a Unify environment with PPSK and I had Wi-Fi 6E access points, I wouldn't forfeit the 6 GHz band. What I would probably do is have 2 SSIDs. One of them using WPA3, a single key, and that works across all bands, so 2.45 and 6 GHz. And that would be my main LAN. So my main LAN with all my devices generally on it would be a standard pre-shared key network. I would then have a second PPSK network that's only 2.4 and 5 GHz. And that would be for everything else. So guest devices, IoT devices, cameras, all that kind of stuff can go on that separate network. Those devices don't need the 6 GHz band, they don't need that level of performance, and realistically, you'll always need to keep a WPA2 network around for a very long time into the future because of all sorts of embedded and legacy devices that you'll have. So that's kind of the way I would do it, is you would have a PPSK network for weird little IoT devices and stuff you want to put on separate VLANs, guests, that kind of stuff, and keep another separate SSID just for your main LAN that's got the 6 GHz band enabled. The other option you could do if you really wanted to have the ability to have multiple VLANs on your 6 GHz band would be to instead have 2 different networks, your PPSK network, which is 2.4 and 5 GHz, and your 6 GHz Wi-Fi 6E network using WPA3 Enterprise. Because what you could then have is a Radius server, all your high-end Wi-Fi 6E devices can connect using a username and password, be assigned their VLANs that way, and then you keep your PPSK network for legacy devices that don't support WPA Enterprise, because chances are those devices also won't support Wi-Fi 6E. So there's various ways you could do it, but it is an interesting limitation, and it's something very important to bear in mind. You couldn't just set up one SSID with all your pre-shared keys on it with Unify and have Wi-Fi 6E as well. You kind of need to have one or the other, or separate SSIDs. But yeah, it's a very interesting technology, but that is one bit of a catch with it that's not very well advertised. But there you go, that's a look at Unify's new PPSK technology. It's a really cool feature. I really love having it on my Ruckus access point, and it's great now seeing it on Unify because Unify make absolutely great access points. They're a really solid option, but they've always just lacked this, and it's a little bit annoying. So it's really nice to see that they've now got it. It'll just be interesting to see how this manages to work out going forward with Wi-Fi 6E and 6 GHz, and what happens when Wi-Fi 7 comes into the picture. How is this technology going to evolve? Will it last, or will it kind of start dying out along with WPA2? So yeah, hopefully you found this interesting or potentially useful if you've got a Unify access point and you want to deploy PPSK. But all I have to say now is thank you very much for watching.